Welcome to EDU World Space.
Looking at friction problems, consider the brake system shown in the board. We want to determine the horizontal and vertical component of reaction at the pin O here. So what we can do is to apply at the condition of static equilibrium to solve this, determine our F, the friction force at B, FB, so B, and normal reaction force, then RB at B, okay, and determine what we are asked to bring out. So that for we've given the moment the torque here to be 50 Newton. Yeah, as you can see. So we can apply the conditions of static equilibrium to be able to solve this problem. So a moment here at O is equal to 0. So we can just get our torque. We know that torque now. The torque is given. So it's going to give us is equals to, and we know that torque is force times radius. So FB times radius. The radius is given as 0.125. So when we apply that, we can just have our, we know that our torque is 50. So from there, we can get our FB. Okay. Plug in your value there. You get your FB to be equal to 400 Newton. Where arrow is 0.125 is there on the board for you, Newton. So we can now apply moment further condition. Summation of moment at A this time. When we do that, just follow the same procedure for determining moment. Look at use this the free body diagram that is there. Okay, you are going to have your NA. You are going to have your NA. Take moment about it. You are going to have your N ROB to be equal to 407.1 Newton. Of course, you can see that if you plug in your F, okay, of course, we know F is equal to is mu N normal reaction at B. So if you plug in your value into this place, you are going to have, using mu at 0.4, you are going to have your F, your frictional force, to be equal to, in fact, you're going to have your frictional force to be equal to 162.9, 2.9 Newton. Of course, this is lower. It's less than what we had there, the 400 we had Newton that we had there. That means there's going to be slip at point B in the diagram there. So therefore, we are going to apply the coefficient of dynamic friction, which is 0.3. So we take as moment again at A, but this time around we are going to apply mu is equal to 0.3. When we do that, we are going to arrive at our NRB. So as we be, we are going to have it to be 154.54 Newton. Okay. Now we can now talk about our reaction components. Now, if you look at the diagram, you can see that NRB is coming down, which is this one. The weight of the drum is also here, which is 225 kg. Sorry, the mass is 25 kg. By the time you multiply by 9.81, you get the weight, which is 245.54 Newton there. Okay, of course, we know this one already. We just calculated it here, 154.54 Newton. Okay, okay. Of course, you can see that there's another force coming up to the point O, opposing them. So by the time you take moment, sorry, you take summation of horizontal force, sorry, vertical forces, okay, equal to zero, you are going to arrive, you are going to arrive at your answer to be equal to 400 Newton. So just do that one, you have 400 Newton as O Y. Okay. Then you do the same thing horizontally, summation of horizontal components, okay, to be equal to zero. So, which is FV or Fx to be zero. When you do that, you are going to have your OX, okay? This is the horizontal reaction component we are talking about. And that's the vertical we just did. So it will give you 46.4 Newton, okay? 46.4 Newton, 400 Newton. So